All right, folks, so we're going to be talking about inverse functions today. So the first thing we're going to go over is just in general what inverse functions are. So an inverse function is what happens when you switch your x and y values. So we're going to start real basic with just points. So if I have the point 1, 0, the inverse would be 0, 1. You're literally just flip-flopping your x and y values. So for the next one, if the point's 3, 1, the inverse point would be 1, 3. All right, I want you to also plot it on your graph. So this is your x, this is your y. So you go left, right, then up, down. So for this first point, I'm going to go right 1, 0 up. And then the inverse would be 0 and then 1. Then the other point's 3, so right 3, up 1. And then right 1, up 3. So go ahead and find the rest of the inverses. 2, 4, 3, 5, 5, 6. And then when you would plot it for 2, 2, 4, 5, 3, 3, 5, 6, 5, 5, 6. So if you notice when you plot them, you kind of get this symmetric looking graph. So when you plot the function and its inverse, you're actually just reflecting it. So what does it look like it's reflected over? It's reflected over the y equals x. So it's basically reflected over a linear equation with a slope of 1, which is this blue line. So anything I graph, to graph the inverse, you literally would just reflect it or copy it to the other side of this diagonal line with a slope of 1. So the first thing we're going to talk about is what does inverse mean? So inverse means, in blatant terms, opposite operations. So the inverse function undoes another function. So opposite operations would be like if your original function was adding 2, the opposite operation would be subtracting 2, so that would be your inverse would be subtract 2. So you're just doing the opposite of what the original wants. So for a point, you just flip-flop all the x's and the y's. So my first point's negative 327, so my inverse point would be 27, negative 3. And then flip-flop negative 8, negative 2. These two are the same, so the flip-flopping doesn't do anything. The 0, 0 doesn't do anything. 1, 1 doesn't do anything. 8, 2, negative 27, 3. And then it asks you, is the inverse relation a function? So remember, for a function, every x needs to only go to one y. So every input can only have one output. So every x, so look at your x's. Every x only goes to one y. Yes, this looks like a function. So then go down to the next one. Flip all the points. And then it asks if it's a function. Well, no, if you notice 4 goes to negative 2 and 4 goes to 2. So this is not a function. So it says, isn't inverse of a function always a function? No. So sometimes it can create something that's not a function. All right, so let's go, how do you find the inverse algebraically? So we just did it with just the points. You just flip-flop the points, the x's and the y's. But what if you actually have like an equation? So if you actually have an equation, here's the steps at the top of your paper. First step is to, I'll number them. You don't have to number them on your paper if you don't want to. First step is to change the f of x to y. So the f of x is on your left-hand side. Write it as y equals, so then you don't get confused. So step one is just to replace the f of x with y. Step two, switch the x and the y. So I'm literally just going to say, I'm just going to flip-flop my x's and my y's. So my x equals, and now put my y with my 2. Just changed them around. Step 3 is to solve for y. So if I have x equals 2y plus 3, I'm trying to solve for this y. So first step would be to subtract 3. These cancels. I'm left with x minus 3 equals 2y. And then divide by 2. Remember, you're undoing everything. That's why it's a inverse. So I end up with x minus 3 divided by 2 equals y. So y is by itself, so I'm good. And then the last thing is just to rewrite it in a nicer notation. So step 4 says rewrite with the f with the little -1. That means inverse. So the inverse of f equals, and then you're going to write what you got for when you solve for x, or for y. So your final answer would be this little inverse notation, and then whatever you got when you solve for y. Go to example 2. So step 1, write it as y equals. So got rid of my f of x and I wrote it as y equals. Step 2, switch your x and y. So my x is going to go to my left. My y is going to go up here with my plus 4. Step 3, solve for y. So remember, you're undoing what the equation has. So this equation is y plus 4 divided by 3. So to undo the division, I first have to multiply. All right, then I have y plus 4. To undo the plus 4, I have to subtract. Okay. Once you get your y alone, the last step is to write it with the inverse notation. So the inverse of f equals 3x minus 4. There's your final answer. So when you're finding inverses, look at your equation, and it should kind of look like you're undoing something. Like in this original equation, I was adding 4 and dividing by 3. So I know my inverse, I'm going to probably be subtracting 4 and multiplying by 3 in some manner, which I am. Multiplying by 3 and subtracting 4. So it's just undoing what you originally have.